During a typical American summer, solar radiation constantly bakes the surface of your roof, turning the enclosed attic space into a massive thermal reservoir, where temperatures regularly climb past 150 degrees Fahrenheit. This trapped heat radiates and presses downward through the ceiling, forcing your air conditioning system to run longer and work harder. In many homes, the ductwork carrying your cooled air runs directly through this superheated space, warming the air before it even reaches your living room. This chart illustrates data from the Department of Energy, showing the exact penalty for that trapped heat. Every single degree of attic temperature increase boosts a home's cooling load by up to 4%. Effective attic ventilation must break this parasitic cycle, exhausting the hot air outside before it has a chance to infiltrate the spaces you're paying to keep cold. Go back just a few decades, and a highly visible solution to this problem sat on residential rooftops across the country: the turbine ventilator, or whirlybird. Independent testing proves these spinning steel cowls are remarkably effective. A properly installed system can drop peak attic temperatures by as much as 37 degrees Fahrenheit and cut cooling costs by nearly 15%, all without consuming a single watt of electricity. Yet, despite the definitive test data and the promise of free energy, these devices have vanished from modern housing developments. The modern turbine relies on a design patented in 1910 by an engineer named Samuel Airt. He built a passive engine that required no human input, no fuel, and zero electricity to function. It operates by combining three distinct physical properties. First is Bernoulli's principle. As ambient exterior wind accelerates across the curved exterior vanes, it creates a zone of low pressure inside the dome, actively sucking hot air out of the attic. Second is the Venturi effect. As that interior air is squeezed through the narrow gaps between the spinning exterior vanes, its velocity increases, further dropping the pressure and intensifying the vacuum. Finally, it utilizes the stack effect. Even on a completely windless day, when the vanes aren't spinning, warm air naturally rises. This creates a gentle upward pressure gradient that pushes hot air out through the static roof vent. These three forces compound on one another, generating a continuous, electricity-free exhaust system at the highest point of the structure. Even a perfectly functional physics model can struggle against the friction of the real world. Researchers at Deakin University tested a standard 12-inch turbine and found it achieved a flow rate of about 150 cubic feet per minute. Inside a massive modern roof space, that translates to an air velocity of roughly 1/3 of a foot per second, which engineers classify as still air. A single unit is often too weak to handle the thermal load of a modern home. Then there is the mechanical degradation. The spinning head operates on cheap ball bearings. Over years of exposure, moisture, rust, and dust inevitably infiltrate that metal housing, turning a silent device into a grinding, squeaking nuisance that echoes directly down into the living space. Installers also ran into a critical engineering hazard, known as short-circuiting. When placed on the same roof as a standard ridge vent, the intense, localized suction of the turbine reverses the airflow of the ridge vent, pulling rain and snow directly into the attic space. The physical fragility of its moving parts and a critical incompatibility with evolving roofing systems ultimately marginalize the turbine, regardless of its sound physics. Homeowners associations also helped drive the turbine to extinction. As suburban aesthetics prioritized clean, unbroken rooflines, HOAs routinely banned the highly visible, industrial-looking metal domes to preserve neighborhood curb appeal. The final blow came from changing regulations. As building science advanced, modern homes were constructed with much tighter, highly insulated building envelopes. Energy regulations, like California's Title 24, began demanding precise, mechanically guaranteed air exchange rates. A passive turbine is entirely at the mercy of unpredictable wind speeds, making it mathematically impossible to guarantee those mandatory exhaust rates. The housing industry chose absolute, verifiable mechanical control over the inherent variability of passive, wind-reliant physics. If you live in an older home in the hot, windy climates of the Sunbelt, a pair of cheap turbines remains a highly effective way to drop your cooling bills. But for nearly every new build today, there is a clear, definitive victor: the shingle-over ridge vent. A full-length ridge vent provides over 900 square inches of net-free ventilation area, double the capacity of 3 14-inch turbines. Because it exhausts evenly across the entire span of the roof, it entirely eliminates stagnant thermal dead zones. Best of all, it achieves this massive airflow with zero moving parts. We eventually engineered a stealthier, maintenance-free way to harness Earth's physical laws, effectively rendering the spinning turbine obsolete.